This video is a sequel to the previous one, which covered the basics of color management. We're now going to look at proofing and printing. Let's start with the relevant menus. The color management options, proof mode, and set color profile are intimately related, but not accessible together in any centralized location. So it's a big help to create toolbar buttons as we have before. Right-click, Edit Toolbar, Edit Options. Go to the bottom of the buttons and click the arrowheads to add it. Now we do the same for View Proof Mode. Tool, Color, Set Color Profile, and Convert with Color Profile. OK. Now at least we can access these menus from one place. When printing, the colors of the image must be fit into the printer's gamut and adjusted so they look right on the print medium. For this, we need a printer profile. Printer profiles are more complicated than the working space profiles that we looked at before. They're specific to the printer, the paper, and the printer settings such as resolution. Major paper manufacturers usually provide profiles for a variety of printers. We're going to use a profile downloaded from Ilford for gold fiber silk paper and a Canon IPF 6350 inkjet printer. If you need a custom profile for a special paper, a number of sources are able to make such profiles for you. If you're really into it, and especially if you print on a variety of unusual media such as fine art paper or canvas, you may want to invest in a printer profiling solution yourself. It'll set you back a little more than a simple display profiler will, but it may be worth it depending on what you want to do. And, just a hint, all you need is the gadget. For most instruments, you can purchase the least expensive software package, then use the hardware with the Argyle CMS open source color management system. Here's our image all ready to print. I'm going to pretend that it was captured in RAW and edited in the Pro Photo working space. As we saw before, we capture an image in as large a space as the medium allows and only reduce it as needed. The first thing we're going to do is view what's called a soft proof that's intended to look like what the actual print will look like. Glowing screen pixels will never look exactly like ink on paper, but with a little practice, you can use the soft proof to get an idea of what to expect. First, we set the proof profile in the color management device options. It's the same as the printer profile. Apply, and we should go to Standard and select Use Black Point Compensation. This tries to make a better fit between the blackest blacks of the image and those of the printer profile, and it mostly applies to the relative colorimetric rendering intent, which we will get to in a minute. We don't have to worry about the rendering intent on this dialog. It's the default for untagged images. OK. Now, we're going to turn on the soft proof by clicking our button here. Note, you have to remember to turn it off before you print. That's why it's best to have a visible button showing the status. The title bar also says Pro in proof mode. This paper-printer combination has a very wide gamut, and the proof doesn't look that much different. Now we'll compare rendering intents. This is accessed in a somewhat unexpected place, the Set Color Profile dialog. We're not going to change the image's working space profile, just the rendering intent. What is rendering intent? Most images, especially in wide working spaces, are liable to include a few colors that are outside the printer's gamut, meaning that they cannot be printed exactly as they appear on screen. Rendering intent determines how out-of-gamut colors are squeezed into the printer's gamut. The relevant ones are perceptual and relative colorimetric. Perceptual squeezes the image's entire gamut to fit the printer gamut. Relationships between colors are maintained throughout, but all the colors, not just the out-of-gamut ones, are adjusted. This may lead to undesirable results if critical colors such as skin tones or products in an advertisement are altered, and it tends to lower the overall contrast and saturation a bit. Relative colorimetric, RC, only squeezes the out-of-gamut colors, possibly along with a small range of colors near the gamut boundary, depending on the profile manufacturer. So, a carefully exposed and edited image with few or no out-of-gamut colors will not undergo any major change when using RC, but prominent out-of-gamut colors, such as vividly saturated clothing or flowers, may block up, and detail may be lost. So, which rendering intent do we choose? Well, comparing the two for this image, RC gives more contrast and clarity, but note that Perceptual has better shadow detail. Having looked at the soft proof, you can go back and edit the image to fix whatever deficiencies are identified, such as boosting the shadow values for RC printing, or toning down the high end of the saturation curve to fit the image into the printer's gamut. Or, if Perceptual handles your highly saturated colors better, such as a vivid sunset, and if you don't mind that the landscape colors change a little, go back and boost the vibrance and midtone contrast if needed. As for the other two rendering intents, absolute colorimetric is like RC, but it doesn't adjust the media's white point. It's for printing a hard proof that resembles how the image will look on newsprint, for example. And saturation is for printing eye candy like spreadsheet charts. If you want to see what black point compensation does, choose RC, then go to the color management options. The effect is subtle, but if you turn it off, apply, then turn it back on, look carefully at the deep shadows here as it's reapplied. I'll do it again. The shadows get a little boost. To get an idea of what the image looks like on another paper, let's go to the color management options and select a matte profile. The image now looks a lot different because the gamut is much smaller on matte paper. And if we compare rendering intents, the shadows are a little muddier with RC. The image is brighter and clearer with Perceptual. Now we're ready to print. First, turn off proof mode. Then go to your printer driver and make sure that color management is disabled. No color management, or let the application manage colors or whatever. Now, File, Print, choose the printer profile and rendering intent, and you're ready to go. Some people like to convert the image to the printer profile before printing, especially if they're sending it out to be printed. One would then choose the original RGB space, such as ProPhoto, as the printer profile, quote-unquote, when printing. I do not believe that there's any reason to do this. If you want to make sure that the image prints correctly, soft-proof it with the printer profile and make the necessary corrections first, but leave the image in its RGB working space. The printing application should do the conversion as part of the process. And manually converting the image to the printer profile plays no role in soft-proofing. Now, just a few more words about printing. How do we get an image ready to print? First, we flatten it. Layer, flatten image. Then we resize it. Layout, document, scale document. Choose normal mode, then right-click the value fields and select your units, inches or centimeters or whatever. Enter your printer resolution, such as 300 pixels per inch, and the interpolation method. I prefer Mitchell-Netravalle. Now, enter the print dimensions, and that is how it will print. After resizing comes sharpening, and print sharpening is a little different from how we learned to sharpen in the sharpening video. When we print an image at 300 pixels per inch, it'll be about 3 times smaller than the image is on screen, and the viewing distance may be greater as well. So the sharpening size needs to be about 3 times larger. The intensity may need to be increased a little as well due to a variety of factors such as ink bleeding or the tendency for ink to spread out a little when it hits the paper. Sharpening for the screen, then tripling the size is a starting point, but the only way to tell is to actually print it, or at least a small part of it. Hint, you can sharpen different areas of one image to different degrees to efficiently compare them. And as you will find out, images that are properly sharpened for printing do not always look good on the screen. That's just how it works. Another step that's often overlooked is the setting of the output levels. This test target has squares for black levels counting up from 1 and for white levels counting down from 254. They may be hard to see in the video. Even if you print it with very diligent color management, there will still be squares at the top and bottom that you will not be able to distinguish in normal lighting conditions. I'm not talking about holding it up to a light bulb. If the first black square that you can really see is 12 and the last white square you can see is 252, then values outside this range will be blocked in the print. Correct it by setting output levels to one step outside this range, 11 and 253, like this. Use the arrow keys to raise the low end of the curve to 11 and lower the high end to 253. These levels need to be determined for every printer profile you have. I add them to the profile file name so I don't forget them, and they need to be applied every time you print. The easy way to do this is to save them as an action. And, while you're at it, there's no law that says you can't include a few other things in that action as well, such as a little brightness boost or a little saturation boost, if you find that these are consistent issues. Which brings us to the universal complaint: my prints are too dark. I will assert that 90% of the problem is that your display is too bright. Turn the darn thing down. If your goal is to show clients your wonderful products or PowerPoint graphics on a screen, or if you sell displays, a bright display is a good thing, and slightly bluish displays look even brighter. So common recommendations for display profiling are 120 candles per square meter and a D65 white point. These are terrible for evaluating prints. Profile your display to 80 candles per square meter and a D55 white point. Then see how your prints look. And if you're making your own working space and printer profiles, use D55 for those too. Go ahead, I dare you. It wouldn't hurt to make 2 display profiles with different brightness settings, one for general use in the web using an sRGB gamut, and one for printing using the native gamut. Now, go out and get a book about color management, and you'll be set.